Hello everyone. In this video, we'll dive in to discuss and going to discuss the main assumptions and preliminary tests that must be verified and checked before applying any kind of parametric test, like such as t-test for one sample test, one sample t-test, or two sample paired t-test, or unpaired t-test. Also, ANOVA, MANOVA, repeated measures ANOVA. Also ANOVA and ANOVA mixed. So first test is independence of observations. Each subject here should belong only to one group. For example, we have iris data set here. Should individual or sample should belong to only one group, either setosa or versicolor. So using table, for example, function iris and select species. So these 50 individuals for each group there should be no relationship between the observations within or between groups. So these 50 individuals should be no relationship between them and these 50 other observations for each group, and also within setosa, or with 50 individuals within versicolor. The same case for the last 50 individuals or samples. So having repeated measures on the same participant, it is not allowed unless you are using a repeated measures, for example, tests like paired t-test or repeated measures ANOVA. Also, the sample or the individual should be selected completely at random to ensure independence. The second assumption is adequate sample size. We have used it or checked it necessarily when we want to compute the MANOVA. So the adequate sample size is a parametric test also. Require a sufficient number of observations, for example here, observations. View, for example, view iris. This is the observations. We have 150 observations here. So in the second assumptions, adequate sample size, small samples can reduce the power of any test. So in the case, for example, of MANOVA, we need to check whether the number of observations is more greater than the number of outcome variable or outcome variables or response variable. Also, we can call also as continuous variables. So here we need to check following the thumb rule to check whether the number of individuals or samples is more greater than the number of outcome variables or continuous variables. The third assumption is the normality, the dependent variable. So called also the outcome variable, the response variable, the continuous variable, should follow a normal distribution within each group. When we have only one sample, so with this, in this case, we must need or we must check whether the variable, continuous variable, or the response variable follows a normal distribution, and when we have many groups, for example 2 or more, we need to check either whether the variable follows a normal distribution within each group. For example, when we need to check the normality for each group on this dependent variable. But if your sample size here, for example, for normality is more than 30, so we can consider it as large sample, as large size also. These assumptions here, the normality becomes less strict because we have a large sample size. The fourth assumption is the homogeneity of variance. The variance of the dependent variable should be equal across groups. So when we have only one group or one sample, we don't need to check this assumption, homogeneity of variance. When we have two or more groups, we need to verify using, for example, either by Bartley test, Levene's test, and also Fisher test. And a non-significant p-value indicates here that the assumptions of equal variances, so we can calculate as equal assumptions of equal variances is met when the p-value is more than 0.005, and when the p-value is less than 0.05, we cannot assume these assumptions cannot be assumed. The linearity, the fifth assumptions, there should be linear relationship between the dependent variable and the independent variable. So the response variable and the explanatory variable. The relationship between these two variables should be linear. We can check it using, for example, scatter plot or correlation matrices for these assumptions. The sixth one refers to absence of multicollinearity. We used it when we might need to assess the MANOVA, for example, or compute MANOVA. The independent, or also we can call it as predictor variables, continuous predictor or explanatory variables, should not be too highly correlated, because MANOVA, the use of when we use it when we need to or we want to assess the influence of many of explanatory variable or predictor variable or also independent variable on one only dependent variable. So the absence of multicollinearity describe that the independent or the explanatory variables should not be too highly correlated with each other. We can check it either using the correlation matrices, because the R coefficient correlation between each two variables should be less than 0.9 or in other case 0.7. So when we have R coefficient correlation is above 0.9 in this case, we cannot assume that these assumptions for MANOVA, for example. And also we generally VIF values should be we can check this assumptions absence of multicollinearity by calculating the variance inflation factor. The VIF, which is the variance inflation factor, using, for example, VIF function from, I think, mass package, or check underscore multicollinearity from a performance package, and this value of VIF, the VIF values should be below 5. And so the VIF value should be less than 5, then when in this case we can assume that this assumption. Moving now to the sphericity test. The sphericity, when we might not need to compute repeated measures ANOVA. The repeated measures ANOVA when the first assumptions aren't met, because when we have the repeated measures ANOVA, we instead to use ANOVA test, we need to use the repeated measures ANOVA. So for repeated measures test, the variance of the difference between each group should be equal. So we can check the sphericity assumptions using Mock-Lee's test. Mock-Lee's test, or also called Moch-Lee's test, it is test to checking the sphericity. If the assumption of sphericity is violated, for example, when we have a p-value, for example, significant, corrections such as Greenhouse Geyser or Weinfeld should be applied. It's applied automatically when we, for example, assess or compute the ANOVA repeated measures in R. The last assumption refers to homogeneity of covariance matrices. Also, when we check these assumptions when we want to compute the MANOVA, for MANOVA, which is the multivariate analysis of variance, we can check this assumption using boxes AM test to check the equality of covariance matrices between groups. Again, a non-significant value means that the assumptions is not satisfied. I think the p-value here should verified at 0.001 level. Finally, remember that in parametric test, the dependent, or also we called it as the response variable, the dependent variable or the response variable must be, not should be, must be numeric and continuous. For example, weight, and value of pH, temperatures, and the independent variable, which is the explanatory variable or predictor variable, should be independent or explanatory variable or categorical variable, should be categorical, so such as gender or treatment group. Finally, thank you for your watching and see you in the next video.